everyone, welcome back to Sri Sampath Vinayaka Learn Easy channel. In this video we will discuss about the different types of subsets like proper subset, improper subset, and also we will discuss about power set. Okay Nama? Firstly we are going to learn what is a subset. Okay? Subset. Let us suppose A and B are two sets. If all the elements of A are the members of the set B, that means all the elements of A are there in B, then we will say the set A is the subset of B, or the set B is the superset of the set A. See, let A and B are two sets. If every element of set A is also an element of set B, then A is said to be a subset of B, or B is said to be the superset of A. Okay, and if A is a subset of B, then we will represent that as A subset are equal to B, or B is superset are equal to A. Okay, this symbol is the symbol for subset and this is the symbol for superset. Okay, now we will discuss one example. See, let A is the set of 2, 4, 6, 8 and B is the set of 1, 2, 3, 4, 5, 6, 7, 8. Then here clearly observe all the elements of set A, that is 2, 4, 6, 8 are also the members of the set B. See in this set B, these 2, 4, 6, 8 are there. That's why this set A is subset of set B. So here A is subset to B, or B is the superset of A. We may write like this. Now coming to the example 2. See set of all prime numbers except 2. We know set of all prime numbers except 2 means all those are odd numbers. Is a subset of all odd natural numbers. Is why? Because except the 2, all prime numbers are odd numbers we know. That is why the set of all prime numbers except 2 is the subset of all odd natural numbers. I hope you understand. Let us suppose A is set of 1, 2, 3, 4. Now we will write the subsets of this set A. Okay, see empty set. Empty set means nothing is there in this set. That means this is a subset of set A. And let us suppose set 1 is the subset of A or not? Set 2. Similarly, set 3, set 4. See all these are subsets of set A. Okay, firstly we write one set, that is empty set, which is subset to set A, and then we write all the singleton sets. That means one element we are going to place in each set. So that's why all these singleton sets are subset to set A. Now I will write two elemented sets. First fix the element 1. Then as the second element I may write 2, or I may write 3, or I may write 4. So with combination 1 I have these 3 sets as the subsets of A. Similarly with set with element 2 write the possible sets. 2, 3 is a subset of A. 2, 4 is also subset of A. Similarly with the combination 3, 3, 4. 3, 4 is a subset. Okay, 2 element sets also we finished. Okay, coming to the 3 elements, 1, 2, 3, fix 1, 2, then 1, 2, 4, and then fix 2, 3, 2, 3, 4. Okay, like that we have to write the subsets. Just count these sets, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. And here one more combination is there, 1, 3, 4 I may write. Okay na? So these are the 15 and the main set 1, 2, 3, 4. Okay, these are the subsets of set A. Firstly we have to write a subset with 0 elements. Okay, and next singleton sets, next 2 element combinations, and then 3 element combinations, and finally the set itself. Okay, these are the subsets of set A. Example 1 this is. Okay, Now I will consider another example ma. Example 2. Okay, let us suppose that B is set of x, y, z ma. Okay, so simply first we have to write empty set, then singleton sets, and then two element combinations ma. Fix x, then to that x I may write as combination y or xz, and next yz. Okay na, and two element combinations over, then three elements ma, x, y, z, the set itself. Okay, so just again count the subsets ma. 1, 2, 3, 4, 5, 6, 7, 8. This set is having 8 subsets ma. It is having 8 subsets. 8 means 2 power 3. It is having 16 subsets we counted. So this is 2 power of 4 ma. Okay, another set we will take. By that we will conclude ma. See, here we will take example 3 ma. C is equal to, let us suppose, P comma Q. Okay, what are the subsets of C ma? Empty set, the singleton sets, and then the set itself PQ. Here count how many subsets it is having. 1, 2, 3, 4. That means 2 square ma. Okay, by this we will generalize that each set is having 2 power the number of elements in that set as subsets. See ma, it is having 4 elements now in this set, so 2 power of 4. Okay, that means its cardinality is n of a ma. N of a is equal to 4, so it is having 2 power n of a. Okay na, subsets. Coming to this B, it is having 3 elements in this set na ma. N of B is equal to 3, so it is equivalent to 2 power of n of B subsets. Okay, coming to this, n of C is equal to 2 ma. Okay, so it is having 2 power n of C subsets. Okay, simply we will generalize that. Let A is a set. If it is having m elements in it, then it is going to have 2 power m subsets. Okay na ma? I hope you understand. Now we will take another example ma. D is equal to A, B, C, D, E. Okay na ma? That implies number of T is equal to 5. Therefore, number of subsets of D is equal to 2 power of n of D. That is equal to 2 power of 5. That is equal to 32 subsets. Here I will tell you one small logic to find out the number of subsets of a specific number of elements. For example, how many subsets are there to this set D with 2 elements? How many subsets are there to this set D with 3 elements? And how many subsets are there to this set D with 4 elements? Like that also we will count. Okay, now for that I will tell you one logic ma. See, to find out the number of subset with 0 elements, 5C0 ma. 5C0 means you have to remember 1. 5C1 is equal to 5. That means number of subsets with 1 elements is equal to 5 ma. 5C2 is equal to, I will tell you the logic. See, here the subscript is 2. 5C2 means 5 into 4. Here we have 2 number, 2 numbers we have to write from 5. 5 into 4 backwards. And from 2 to 1. 2 into 1. 2 1s are 2 2s are. 5 2s are 10. That means 2 elemented subsets are 10. 5C3 ma. 3 elemented subsets I want. So here I am having 3 ma. From 5 I have to go back 3. 5 4 3. From 3 I have to go up to 1 ma. So this 3 and 3 will cancel. 2 1s are 2 2s are. 5 2s are again 10. 5C4. 5C4 means, see ma, 5 into 4 into 3 into 2 into 2. That's it. Why? Because 4 numbers backside we have to move. 4 into 3 into 2 into 1. See ma, this 4 into 3 into 2 will cancel with this. Then 5 left. 5C5 is again 1. And one more logic is 5C0 and 5C5 are same. 5C1 and 5C4 are same. 5C2 and 5C3 are same. This is the logic to find out the number of subsets of the specific number of elements. Okay, see here 5C0, 0 elemented subsets is 1, that is empty set. 1 elemented subsets are 5, those are set A, set B, set C, set D, set E. Okay, nama? 1 element also we obtain. 2 elemented combinations we have to write. How many those are ma? 10. See ma. Fix that A. Fix A ma. Then I may write B as the combination for A. AC, AD, AE. With A the combinations are over. Fix the second element as B. Next third element, see ma. Here the second element is C. With B the next combination is D. With B the next combination is E. Next with C. With weak all the combinations are over. CD, CE. With C also the combinations are over. Next DE. Okay nama? With E there is no other element to form a combination ma. Once count the combinations with 2 elements ma. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we obtain. Okay na? 2 elemented subsets as 10. Now 3 elemented subsets we have to write ma. For that fix A and B as the first 2 elements. Then C is the combination as third element ma. A, B, D. A, B, E. With A, B the combinations are finished. Now fix that AC as the second pair ma. A, C, D. Okay na? A, C, E. With AC also combinations finished ma. Next with AD. A, D, E. Okay na? There is no other combination with AD ma. With AE also there is no combination. Why? Because after E there is no letter to write. Next here fix that BC ma. BCD and BCE. With BC also the combinations are over. Fix BD ma. BD as 2 elements and third element as E ma. BDE. Those combinations are finished. BE there is no other combination with BE. Coming to the CDE. Okay, finished ma. Now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 elemented subsets are also finished. 4 elemented subsets we have to write ma. See here. Fix this ABC as the first 3 elements. ABC, the third element as D. Fourth element as D ma. A, B, C, E. With ABC the combinations finished. A, B, D, E. Okay, next ACD. A, C, D, E. Okay nama. Next with AC there is no combination. ADE also no combination. With BCD. BCDE. Okay nama. See here we obtain the 4 elemented combinations 5 ma. So 1, 2, 3, 4, 5. Now 5 elements, the set itself, that is A, B, C, D, E. So these are the 32 subsets of the set D ma. Okay. By observing all these subsets, we will notice that empty set is subset for all the sets and the set itself is also a subset for the set. Okay. Like factors. In factors what we discussed ma, one is factor for all the numbers and the number itself is a factor no. Similarly here in sets, empty set is subset for all the sets ma, and also the set itself is a subset for the set. Okay, now we will discuss the observations in subset concept ma. See here we observed that empty set is subset of every set, and also we observed one more point. The set itself is a subset for the set. So every set is a subset to itself. These are the 2 main points we observed. Again, one more generalization we obtained. That is, if set A has m elements in it, then n of A is equal to m. Then the number of subsets of that A is 2 power n of A. That is 2 power m. Okay, Nama? This is the most important generalization. That means number of subsets are 2 power its cardinality. Next, the number of non-empty subsets. Non-empty subsets in the sense, from those subsets I have to remove the empty set. How many empty sets are there? Only one, no? That will be subtracted. So, 2 power of n of a minus 1 gives us the number of non-empty subsets of the set A. That is 2 power m minus 1. I hope you understand. We will discuss it with an example. Let A is the set of 1, 2, 3. Then its cardinality is 3. Number of subsets of A is 2 power of its cardinality, that is 2 power 3, that is equal to 8. So 8 subset it is going to have. These are the 8 subsets. We already discussed how to write the subsets. Now, the second point. The number of non-empty subsets of the set A is 2 power n of a minus 1. That is 2 cube minus 1. That is equal to 8 minus 1, and that is 7. So, except this empty set, the rest of all the subsets are known as non-empty subsets. Okay, na? I hope you understand. And one more important concept is power set. What is a power set means? If I will place all the subsets of the given set in a set, that means set of subsets. Set of subsets is known as a power set. We will discuss it clearly. Power set. The set of all subsets of a set A is called the power set of A. So it is denoted by P of A. If it is set A, then P of A. If it is set B, then P of B. Okay, Nama? Example, let us see. A is the set of PQR. Then we know its cardinality is 3. Then the number of subsets of A is 2 power n of A is equal to 2 power of 3 is equal to 8. We know how to write the subsets. These are the 8 subsets of set A. Then power set means if I will place all these subsets into a set. See, I placed all these subsets into a set. Then the newly formed set is known as power set. How many subsets it is? Of 8. So, number of the elements of the power set is 2 power of number of A only. That is 2 power of 3, that is 8. That means number of elements in a power set is equal to number of subsets of that set. I hope you understand. Now, proper subset. Proper subset means if A is subset to B, then okay, A is said to be proper subset of B if A not equal to B. That means we have to write all the subsets except that set. Why? Because see, if I will write the subsets of this A, then see empty set P, Q, R, set of PQ, set of PR, set of QR, and set of PQR. Out of this, see this empty set is subset to A, singleton P is subset to A, singleton Q is subset to A, singleton R is subset to A, PQ is subset to A, PR is subset to A, QR is subset to A. All these are smaller than this A. The final set, that set itself is equal to this A. That's why this set is not considered as proper subset. Okay, rest of all the subsets are proper subsets to this set A. Okay, that is the definition indicates. If A is subset to B and A not equal to B, then A is called the proper subset of B. Okay, in the subsets which are not equal to the given set are known as proper subsets. That means if A is a set, then it is going to have 2 power of n of A minus 1 proper subsets. Why? Because except that main set, rest of all the subsets are proper subsets to the given set. Okay, Nama? That is the generalized observation. See, number of proper subsets of any set is 2 power of its cardinality minus 1. Why we are doing minus 1 means we are removing that main set. If I will remove that main set, then rest of all the subsets are proper subsets to the set. Okay. Next, number of non-empty proper subsets. That means we have to remove that empty set also. Why? Because here he asked us to write non-empty proper subsets. Okay. This empty set is also a proper subset, but he asked us to write non-empty proper subsets. So from this we have to remove this empty set also. Then the rest of all 6 subsets are non-empty proper subsets to the set A. And now listen, Here we removed that main set. That main set is known as improper subset. Okay, all these are proper subsets, no ma? Now that removed one, that means this PQR, the set itself is known as improper subset. So the set itself is known as an improper subset, ma. How many improper subsets a set have, ma? Only one. Okay na? See, the number of proper subsets are equal to number of subsets minus 1. Number of non-empty proper subsets means number of subsets minus 2. Okay. And the number of improper subsets is always 1. Okay nama? And finally, one observation, any non-empty set is going to have minimum 2 subsets. Those are the set itself and empty set, ma. That means sometimes he will ask you how many minimum number of subsets a non-empty set is going to have. That is 2, ma. If you will consider any non-empty set, that will have minimum 2 subsets. Those are the set itself and empty set. I hope you understand this concept of subsets. Okay, thank you for watching, ma. Please like, share and subscribe the channel and share with your friends also. Thank you so much, ma.